Hi guys, welcome to Learn Electronics Repair. I have an amplifier here, another one, Powersoft D4002, okay? This came from the guy at the other side of the island who brings me quite a lot of things to repair. He says this was working and it went bang. Yeah, it went bang, this one. And we can see this is what's inside it. This smells like something burnt, but it's a bit hard just sniffing around to figure out where that's coming from actually. Could be this area, but hard to say. So, what do we have here? First impressions. Well, we have power coming in here. So this is your mains input, okay? Goes onto this board. And I would say that together with this is the power supply. Okay, this is your power supply here. Two transformers on there. Could be a dual power supply. Has this board here which kind of like bridges across to there, okay. So that I would say is your power supply. This amplifier, well, that goes to the speaker connections here, okay. So XLRs are the audio inputs and these are your outputs, okay. Yeah, it tells you how to connect as a bridge or a stereo. So that is your input and output. I think we very clearly have two amplifier boards here, or two amplifier channels, but this one's on the same PCB as the power coming in, and this is on the same PCB as the connections going out, okay. We have two like transformers here, one different there. So that's what we've got. I think the first thing I'll try with this is, do I have a schematic for it? And Electro Tanya, good old Tanya, yeah, has something for me. I am not a robot. Download. So you can get 10 free files a day from this site. You can join, of course. They have a repair forum on here also. So let's download this one, see what we have. Lots of files. All PDFs. Okay, I'll have a look to see if this matches my amplifier. Well, the first thing, it looks like mine. Yeah, this looks like mine. That's promising. Yeah, these are all the layouts for the various boards. These are schematics, all these. Yeah, all the layouts. What about these? Schematic, I guess. Yep, we have schematics, guys, so we have a chance with this one. Let's see where we should start. Well, from what I can see, there's a few variations of this. So this file, ALIN, yeah, and we can see there's some different ones, slightly different versions of this one. If I just go to the other ones, you'll see, so all these ALIN, see there's one there, there's one here, and they appear to be just different versions of this. This is the power supply, so we can very quickly get an idea what we have here. This is your mains in, 90 to 265 volts, filters, bridge rectifier. This is clearly PFC, current sense resistors here, look, PFC, two MOSFETs on it, being driven together. There's the diodes you find in the PFC circuit. In fact, there's a couple more diodes on this one. Those look like your high voltage capacitors here. 33 microfarads, lots of them, yeah. Strange, I thought they'd be bigger than that, but that's what they are from what I can see. That's then driving here, so These are the MOSFET drivers, these are the MOSFETs. So the drive signals come from somewhere else, okay? That's your primary. This is a secondary loop for diodes, bridge rectifier. This is ground. There's a Zener here. There's an opto in this. And this looks like plus and minus 32 coming from somewhere. On the output here, what we have, plus and minus 60. But I looked on another one, it was plus and minus 90. So there's this variance of this one. Plus and minus 32. If we go to one of the other variants, we'll see the difference. Look, plus and minus 90, plus and minus 32. Yeah, lots of capacitors on here. I'm not sure what this funny little thing's supposed to mean, but yeah. Yeah, your plus and minus 32 comes from here, goes into this connector. That'll probably end up driving a plus and minus 15 somewhere, I would think. Yeah. So that's the power supply, depending on which model we have. This one, I'll sue. This might actually be the controllers, the drivers for that power supply we could see. Wouldn't be surprised. There may be a main supply and a standby supply as well. Okay. I'm in. Various versions again. Some of them show like a block here. And some of them show that as a load of logic. Yeah. What's this one doing? This one, I'm in. Yeah, this is your output stages. Look, you have some plus 90 volts here, very low value resistors, MOSFET, inductor MOSFET, low value resistors, minus 90, okay, and then output from here by the looks of it. Some sort of filter or even monitoring the filter like a transformer. Capacitors and output. So this is your speaker on connector. So these are your speaker connectors, okay, for the bridge or for the normal mode. So that's the amplifier output. We can also see here, yeah, look, this is your plus and minus 32 generating plus and minus 15, exactly as I expected we would have somewhere, okay. Protection circuitry and that sort of stuff here. And then the other one, AMSU, is like the input part of the amplifier. So this will be where your audio comes in by the looks of it. Yeah. Temperature LED and various things. Feed in, feed out. So this is kind of the front end of the amplifier from what I can see. Okay. So we know basically what we have here. The first thing I want to see is, are any of the fuses blown? And do we have any shorts anywhere that we can see? Okay. And the obvious place of looking for the shorts is in the power stages, yeah? For the amplifier and for the power supply. Okay, so first, fuses. Reads okay. Reads okay. Reads okay. Reads okay. Assuming this is the power supply and this is the amplifier. And it looks like, yeah, you could have another one with another board here as well. Okay. It's difficult to get to all the power devices that are under here, but what I can do is check here. So I can see this is marked ground plus V and minus V. Yeah, so I'm fairly confident this is probably the high voltage. Yeah, fairly confident. So if we measure from ground to VCC, what do we have? Well, that's fairly low. I mean, 30 ohms, and considering this is like 90 volts, that's 3 amps. Yeah, and that's without anything effectively powered up. I'll look on the other one. So this is the negative rail, so connect the red meter lead to ground and the black to negative. Let's see. Well, it's a bit higher, so I'd expect them to be basically the same, especially with the polarity, the same equivalent. If I disconnect these, if I can be a bit tricky, these things. Yeah, I got it. Okay, the last one's going to come off. Okay, so we'll disconnect those and let's have a look on the output from the power supply. What do we have? Considerably higher. Okay, and to the negative. Well, lower than the other one. What about on these? So, ground positive, 36, ground negative, much higher. So I think we quite possibly have a problem here, both on the amplifier and the power supply board. I'll see if I can get this amplifier board out and then we can have a closer look at that one first. We can always power this up without the amplifier attached and then see what it does. With a light bulb limiter on, of course. Okay, I've got the amplifier board off and we can see some evidence here, yeah. We see some evidence of some violence. Yeah. Charred. So that's part of the problem, but that might be because of a short causing a lot of current to come through there. And look at this. Same. Well, in fact, this is what's charred that. So there's the first evidence of trouble, and that's what I could smell burnt. Well, that tells me I have to take this board out as well, but let's have a look at this one first. Oh, lovely, just what we wanted, yeah. So what do we have? Well, there's a track which goes along here. Looks like another track which should go up that way. No, there's two more tracks actually. This one. Okay. And this one. So that goes to that, I would say, and this goes to this. And then we have something else here. Another track. Coming in from somewhere. A wider one. Okay, so we have some quite bad PCB damage here. That's the first thing. There are three connections here, so I'm guessing, well, there's 1, 2, 3. Well, one goes to there. One of the connections is here, one is here, one is there. Okay, so we have that. And what caused that to happen? What caused that to happen? Well, 1, 2, and 2 big ones and another one. Yeah, 5 devices. 5 devices, okay. I think some of these are diodes actually. This looks like a diode because those two are connected to each other. Maybe not that one. I'm not sure about that one. Yeah, it reads like a diode. Is this one the opposite direction? Yeah. Red in the middle. Yeah, so those are the equivalent of these ones. Not that way, but this way. Yeah, and this one this way. Yeah. So they both read with the black in the middle. Yeah, those four read like diodes. Okay. This one. Looks like a parasitic diode there. Probably a MOSFET. I'd have to take these out and test them, I think. But there's no shorts. This one. Looks like a MOSFET again. Parasitic diode. This side. It looks like a MOSFET on that one. Okay, so I don't see any shorts around these. I thought I might do. Interesting. To be certain, I would have to take them out. But the fuses are not blown, remember. The fuses are okay, so I'm wondering now if effectively we had a bad connection on one of these and it's effectively caused this to get hot and burn up. Yeah, look, if we go on the power input now, it actually is a negative. That's like there's a capacitor with some charging somewhere. Probably from my multimeter. Just try shorting these things. Okay, go again. So ground to negative. Reads high now, and then ground to positive. Well, it's in the kilo ohm, so that low resistance has gone away. Do you think that was just charred PCB? Okay, let's look at the power supply. Yeah, and we find the same sort of thing under here. Something burnt there. Okay. It's like it's metal. Huh. That's metal. Rusty or corroded, but it's metal. And what do we have? Same sort of thing. Okay, well, I'd say that piece of metal is probably a piece of this copper track. I mean, something here is seriously either arced over or passed a lot of current. Yeah, look at it. Well, I'm sure we can say that this one goes to this track and this one goes to this track and that one probably connects on the other side. Maybe. Yeah, that one connects on this side, okay. What resistance do I see on these now? Ground plus. Climbing up quite nicely. Ground negative. Climbing up quite nicely. So it looks like the only problem with this is this charred area of the circuit board, and the question is why? Here we can see the damage. So 2 tracks broken here, 1 here. Possibly I would think this one goes to there because I can't see how it would go any further. Something goes to here. The other one, well, I mean, there's a track there, so it might actually go there. But I have the schematic, so I should be able to work that one out. This one is much simpler. So this is the plus and minus and the ground connects on the other side. So this one, I think what we'll do is power this up on the bench and let's see if the power supply actually works. The ground obviously connects on this side of the board anyway, okay? And the other two, well, although there's a chunk of track missing there, we have quite a bit going to here. And I could actually run some thick wire down here to there, and the same here, just to make sure I have a good connection, because it looks like that's gone a piece there as well. And then these are the two separate tracks here, okay? We have a bit of this burnt stuff in here, but I think I've got rid of most of that. Okay. We already know there were no shorts here. Let's just have a quick look again just at the resistance. So 1.25 mega ohms. There's a capacitor in the circuit. This one's charging. And we're now into the mega ohms. Okay. This has like little plastic standoffs, so it's not actually on the bench. Although these anti-static mats are not actually conductive, but I generally don't like putting high voltage stuff directly onto it. I'm not sure why. Okay. So let's see what voltage we have coming out of this thing, if any. Just clip the ground lead on. If you want to be sure that your cable is good, just go to ohms range. Yeah, we see a reading, so therefore the cable is okay. Right, volts. A light bulb, but this is only a 65 watts, so it might actually come on to some brightness anyway, or it may flash brightly, which is the PFC on here trying to kick in. So let's see what it does, okay? It's got some brightness on that. This is drawing a fair bit of power and there's no load. Let's just connect to the output of the power supply. What do we get? There's nothing coming out of it. So it's drawing a fair bit of current, but nothing comes out. That might be because the 65 watts is too low. So I'll connect my other current limiter in, the higher powered one. Okay, so this has two bulbs in, this 72 watt each, so about 150 watts roughly here. Let's see how this behaves. So again, I'm just on one of the outputs. Let's power it on. What does it do? Well, it seems happy with that, and it powered up. Okay. There's a green LED on. Oh, then it flipped. So it's trying to power up, so I'm just going to switch the limiter out now. Don't need it. Okay, just directly to mains. And let's go again. So once again, I'm on the output. We had 34 volts there, so it's coming up. Let's see. 99, 100 volts. 100 volts. So the power supply is working. Yeah, I mean 100 volts on the outputs. This will take a while to discharge, so I'll use the capacitor discharger actually, because yeah, bit of voltage in there. Okay, this is my capacitor discharger. It's a bit slow this, but it does the job safely. Okay, just go to volts range and start to discharge the capacitors. Told you it was a bit slow. It needs a lower value resistor on it, to be quite honest, but if you have a bit of patience, this will do it. That's the negative rail I'm discharging. There's also the positive one. So I'll get the caps discharged, and then let's have a look at that amplifier board. With the amplifier board, first of all, I need to find out where these broken tracks go to. Now, I do have a layout, but I can't see the PCB tracks here on the other side, well, actually on both sides, but it doesn't show them. So I'm going to have to work it out by just tracing this through. Looking at this, it seems fairly obvious that this one kind of like went through a 45-degree angle there and joined onto that one. But this is not so difficult to trace because we can see that the track here goes, well, it goes to 3 places here. Okay, and here the 3 places are these power resistors. Okay, there's no component IDs marked on here, maybe underneath where you can't see, but we have the schematic and we have the layout. The other end of that track, the 3rd one in, goes to here. Okay, just get a focus for you guys. There you go. Goes to there, and that is the end of this resistor. Okay, and we can see a capacitor, and that's marked C119. Okay, and we can also see that this board is QAMIN 14. Okay, and if we look on the layout, these are those 3 power resistors, R110, 111, 112, and then there's C119 and R149 and R148. Okay, and the 2 resistors connect to each other. Sure you heard it, but you can see it as well. One end connects to each other, it's this end, okay, which is here, and if we look on the schematic, it's here. So I actually did a quick search, just Control F, R149. I found that, and I can see that one end of 149 goes to 148, which is next to it, and then the other end goes to these 3 R110, 111, 112, the big power resistors. So we know where it goes to. So we know that track. It's the other one that's a little bit more tricky. So this one either goes to here or it goes to here, and it looks like that's the other end of the track there. Yeah, yeah, that's the other end of the track by the looks of it. So I'm confident enough it goes to there. Now that point, which is the middle of the 3 wires, this is ground. Okay, so this is ground, which means that whatever's on this 2nd wire down is connecting to ground, and it goes to like some sort of via here, which unfortunately is very difficult to trace because that via is right next to where this PCB is, and I don't think I can see it. I think it may be under the PCB. Yeah. It's here, opposite to this. Yeah, it's where like this white mark is here. It goes. What's this stuff here? I think that's just bits of either a Beatles antenna or just bits of fluff. I don't really know what that is. Whatever it is, it comes off. Well, it doesn't conduct, so that's a good sign. It doesn't conduct. I think that's a piece off my brush I've been using for cleaning up, actually. Looks the right colour. Okay, we won't worry anymore about that thing. But this via, I don't know where it goes. It doesn't go to this board because all the connections to this board are here. To there, okay. It's after that, it goes under there somewhere. And without taking all this off, it's really extremely difficult to say. But we can maybe take a guess. I suspect it probably is ground. Let's see. Yeah. Well, I think it's safe to assume this is ground. Yeah, and that connects to that track. So that track actually, I would say, does go to ground, which is where it appears to go, because we have a bit of broken wire there as well. So let's fix that one up. And then let's see if we can test this. So, because of a bit of burnt PCB here, I mean, I think it's probably okay. But rather than just repairing this here, I think I'll cut this off. And I'll probably just solder from there because that's where it goes to. And I'm going to run a wire to here because that's where it goes to. And then we don't have to worry about any arcing over or any problem here from the 100-volt terminal, okay? It's probably a bit messier this way, but I think at the end of the day, I'm happier with it. So we'll take this piece off. Just strip it a little bit further back. Okay, you're gone. And I'll do the same with this one. Okay, it's gone. And I run a piece of wire. I don't think this is too thick. Yeah, it fits under the edge of there. Try something a little bit thinner than that. Okay, so from the resistor here, you see it's soldered on. That's actually the leg of the resistor, the original leg. So we can just check there's no short here. I think it's okay, we'll soon find out. So we can see that all this area is ground, so that connects to there. So if we go from there to end of the resistor, and we don't have a short, okay. So that's fine. That then solders all the way down to here. So this is where the other resistors were. We have a good connection. Then the black one from here, I actually cut some of the track away and soldered it here. It actually goes off all the way up there somewhere. I could have actually soldered it to there. That's where it's connecting to anyway, so we have a good connection there. That's fine. And then the last track, I've left it intact. It actually goes even further up the board. That's this one. Now I can actually just get my probe just under there, okay. This one goes from here. And it goes all the way up to here. And we have a good connection. So I'm going to put some epoxy on here now. I'll actually run a little bit of the epoxy underneath this trace as well, just to get away from the board. But there's no charring in this area now. And a bit of epoxy will just hold all this lot down, okay? This looks just fine to me. And that one. This is where the big thick wire solders in, and the power actually comes in here from this end, so it's not flowing that way. Again, well, this one's fine anyway, so it connects there, and this one is ground, and that also connects to a very wide track on this side of the board, you can see here, so that should be fine. I'll put some glue on, we'll let it set, and then I'm going to try and test this before I fit it back on the amplifier, at least to see if there's no shorts or major problems. Okay, so that's effectively reinforced that part of the PCB. Covered over where the solder joints are. I didn't bother with that one because I know it's good anyway. That'll hold the wires in place. So we need to let that set, and then let's see what we can do to test this amplifier. The glue is set now, so that should protect that quite well. What I'm going to do now is connect this to my dual bench power supply, plus and minus. Now, this runs on plus and minus 90. We know that. The bench power supply will go to about plus and minus 30. But if I can put plus and minus 30 into this, obviously with the current limiter on, and it doesn't draw much power, then I know there's no major problems on this, and I'll connect it to the power supply and see what it does. So let's try it first on my bench power supply. I've connected the leads from the power supply then, VCC minus, ground and VCC plus, which is the red wire. Okay, so they connected to the dual output supply. I've set it to 3 amps, which is the maximum on this supply. Let's see what it does. And it's drawing basically no current. Okay. In that case, I don't need to see if anything's getting hot because it's drawing no current. What voltage do we have? Just check, make sure this is getting as far as here. I mean, there's no reason why it shouldn't be. Minus 31. Plus 31. So, if it does nothing with plus and minus 31 on, let's connect it to the proper power supply and see what happens. And of course, I also need to do something with this as well. So this is where it's actually burnt through this plastic sheet. I could just stick insulation tape over, but I'll try and do something a bit better. I can find like this plastic sheeting and scrap ATX power supplies quite often, so I'll probably cut a piece from that and then try and fit it so it goes over a couple of these mounting posts, and then when the PCB is bolted in it can't move. Okay, I've cleaned this up, guys. This is metal. Okay, I couldn't just lay my hands on a piece of like this plasticky stuff out of an ATX power supply, but then I had another idea, plan B. So this part of the amplifier, there's no board fitted in here. This is clearly designed so you can have a different rear panel on here, look, with more connections on for speakers and inputs. You can have another amplifier there that may or may not require a different power supply, but there's nothing there. So I've actually just taken the piece out of here. These mounting posts with exactly the right position for me to fit this here. It just fits over there nicely and covers over that part, and this is the same as the original material, so the insulation's back again, and this will have the same fire resistant qualities of the original stuff. Yeah, so let's put this back together and see if it actually powers up now. Guys, it's all back together. So this is where I took that piece of the plasticky stuff from. You can see nothing's anywhere over there anyway, never will be, so not a problem. One thing I did note, and I'll just mention this actually, so where these power leads came in, where it was badly damaged, you'll see there's a pass through here, which obviously is meant to go to another amplifier. So if this had been worse, the damage here, you could have connected obviously some longer wires but jumped across to this side. Yeah, obviously you still have to fix those small tracks I had to fix, but that's another way. Yeah, you can see it's all kind of in parallel. That's why we have these thick soldered wires here to take the current, so that would be another way. I know the power supply works. I know that I could put 30 volts plus and minus on this and nothing untoward happened. I'll connect it with the current limiter, but remember before it was flashing, it wasn't like working because of the PFC, but at least it'll help me if something drastic is going to happen. Yeah, so we can do it this way. I would expect probably, or hopefully, that bulb will come on, go dim, then flick a couple of times. I know that this is going to power up. So it's switched on at the front. Let's see what happens. Yeah, that flicking and flashing thing. So it's not going to go bang. So we can just take this out of the circuit altogether, switch it out. Yeah, or in fact, it's just in the way. I'll just unplug it now. I've put the camera so you can see the lights on the front. We're going to plug it straight into the main, so let's switch it on and see what it actually does. Well, it says ready. Yeah. I noticed the fan wasn't spinning, but it probably wouldn't spin unless the thing is getting hot. I'm sure it would have some temperature sensing on that, to be honest. Let's connect some speakers and an audio signal and see if we get any music out of this. We'll power it on. Yeah. Seems fairly happy. Let's give it some music. Bit of Northern Soul as usual. Okay. So it's working. Okay, so just a quick test there. What I'm doing with these amplifiers now, I don't have a dummy load for amplifiers. I really need to get my ass in gear and do that. Yeah, get my finger out today and actually build one. So because I have such a good relationship with this particular customer, I'll test them. I have audio coming out of both speakers. It sounds fine. So I'll give him the amplifier back, and basically I say to him, look, this is the price. Go and test it first. Yeah. And if he says it's fine, he pays me. And as I say, I have a good working relationship with him, so I'm happy with that. And he is too. So, okay guys, another one fixed as far as we can say. Any more problems with it? No doubt you'll see it again, but I suspect this will be just fine. I think, in all honesty, the fault was caused by that rusty looking metal washer that somehow got in here, although I can't really see how it would because it's pretty much enclosed. There's no gaps as such. Oh yeah, you can get him from the front. If it got down, dropped in under here and went under that, that would then slide around under the boards. Yeah, so I think that's what ended up over there, and maybe a bit of vibration, bumping or whatever, it shorted it out. Yeah, fortunately it looks like all the electronics survived. Okay, hope you enjoyed that, and I look forward to seeing you all soon again on Learning Electronics Repair. Ciao for now guys.